Hi, this is Alex from devstories.eu, Python Cheminformatics and AI, episode 22 of 22. You have built a state-of-the-art AI drug discovery pipeline on your laptop, but how do you screen a billion molecules over the weekend? The answer is deploying Cheminformatics in the cloud. Moving a model from a local environment to a distributed cloud architecture usually fails at the dependency layer. RDKit is not a pure Python library. It is a large C++ codebase that requires system-level dependencies, most notably the Boost C++ libraries. If you provision generic cloud servers and run standard installation scripts, you frequently hit compiler errors or missing shared object files. The official RDKit documentation highlights that building from source requires a specific C++ toolchain. While precompiled pip wheels exist, the most robust way to guarantee all underlying dependencies align is using Conda. However, installing Conda dynamically on thousands of temporary cloud workers takes too much time and introduces network instability during scale-up. Here is the key insight. You bypass the dependency problem completely by wrapping your pipeline in a Docker container. You write a configuration file that specifies a base operating system. Inside that container, you install a lightweight Conda environment, pull the compiled RDKit binaries, and add your machine learning frameworks like PyTorch or XGBoost. Finally, you copy your pre-trained model weights into the image. Building this image freezes the entire stack into a single immutable artifact. The cloud provider only needs to know how to run a standard Docker container. The complex C++ dependencies are securely locked inside. To process millions of molecules, you separate your data flow from your compute workers using a cloud message queue. You partition your massive dataset of SMI strings into smaller, manageable chunks. You place these chunks in cloud object storage and send a message containing the chunk's location to the queue. You then point a scalable cloud compute service at this queue. For heavy GPU-accelerated workloads, you deploy your container using a service like AWS Batch. For lighter CPU-based inference, serverless container platforms like Google Cloud Run or AWS Lambda handle this perfectly. You configure the compute service to scale automatically based on the queue depth. If there are 50,000 messages waiting, the cloud controller spins up thousands of identical Docker containers simultaneously. Each container connects to the queue and claims one message. It downloads the corresponding chunk of SMI strings, RDKit converts the smiles into molecular graphs, computes the required descriptors, and passes them to your machine learning model for inference. The container writes the highest scoring molecules directly to a managed cloud database. Once the chunk is processed, the worker deletes the message from the queue and grabs the next one. When the queue is empty, the cloud infrastructure terminates the containers automatically. You only pay for the exact compute seconds your code actually consumed. Scaling cheminformatics is rarely about writing faster loop structures in Python. It is about packaging your environment reliably and using decoupled cloud architecture to process data in parallel. That wraps up our series on Python cheminformatics and AI. I encourage you to read the official RDKit documentation on installation, try containerizing a simple script hands-on, or visit devstories.eu to suggest topics for future series. That's all for this one. Thanks for listening and keep building.